Welcome and thank you all for joining us today for our Winncom Technologies engineering webinar, Industrial Connectivity Solutions, Transforming Oil, Gas, and Mining Operations. Here to present from Winncom is our Regional Technical Manager, Dave Thakurdin. And if anyone has any questions throughout the presentation, please feel free to add them into the chat and they'll be addressed at the end of the session. Dave, you're up.
Hi guys, welcome to the webinar. Welcome to Winncom Technologies. My name is Dave Thakurdin. As Don said, I'm an engineer with the Winncom engineering team. Today we're going to do a little discussion about a different vertical to our more common verticals. We're going to go with a little bit of an industrial angle today and discuss two specific markets, which are oil and gas, tend to be clumped together, and then mining, which is also in the same category but slightly different. First and foremost, I'm just going to introduce Winncom Technologies to those of you that might be new to Winncom or have not even heard of Winncom. Let's see if I can advance the slide. Here we go. So Winncom Technologies is a premier global distribution company. We are a distributor of manufactured products in the wired and wireless realm, as well as accessories to those products. We have a pretty wide portfolio of products that I won't go into everything, but what I will do is talk about them as they relate to the industrial verticals. Specifically, like I said, today we're going to be talking about oil and gas and mining, but we're not limited to that. We're just going to focus on those for now, and you'll see some similarities between the other verticals that we do talk about. And we can talk about online or offline in the future. Winncom themselves is a worldwide distributor. We literally mean worldwide, so North America, South America, Central America, Europe, and Asia. We cover all bases. We have offices in many locations. We have hundreds of employees. We are, what I'd like to emphasize from my perspective as an engineer, we are an engineering-driven company. So we're not just selling products. We are actually sticking our engineering noses in to see, do you have the right products? Can we help you expand your vertical? Can we expand the idea of what you're doing? Do you need design help? Can we provide a more accurate bill of materials? And then as well as that, can we be a second set of eyes for you? We know that a lot of you guys know what you're doing, but we also have a little bit of experience ourselves. From the engineering side of things, our engineering team is pretty large, and it's also pretty vast in terms of we each come from different backgrounds. I'm here talking about some of the industrial avenues because that is one of the verticals I've specifically worked in, mining specifically. I've also worked in hospitality. I've also worked for WISP type environments, public safety. The list goes on, and then that list also applies to many of my coworkers in the engineering team. And that's why we feel like we have a little bit of expertise to talk about these subjects. The other thing about Winncom is that we, as a distributor, we are kind of in the middle of everything. We're not integrators, we're not installers. Some of us have a background in that, but we're not currently climbing ladders or turning screwdrivers, but we do talk daily to customers like yourselves who do these sorts of things, whether you're climbing a tower, a rooftop, crawling through an attic, trenching fiber, you name it, we've talked to those customers. We do a lot of our learning from you guys, as well as having our own expertise. So that's where Winncom comes into play. We're your warehouse, we're your store, but we're also your advisement group as well. So moving on, let's talk about what we came here today to talk about. I just wanted to do a quick definition of what industrial environments are. The list is long, but some of the typical examples are shown here. As far as industrial environments in general, I would say industrial environments, but not specifically, could be where you see guys like this. Someone wearing a hard hat, someone wearing steel toe shoes, a safety vest. There's usually some kind of production or blue collar type work going on that needs a different type of strategy when it comes to, first and foremost, is safety. So those environments could be oil and gas, or an oil rig, mining, an open pit or an underground mine. Ports are very industrial, where you have a lot of moving parts, loading, unloading, cranes, forklifts, etc. And then you'll start to see all the overlap here. Wearing a hard hat, everyone's maybe using some kind of industrial equipment. Like I said, forklifts would be one of the easiest ones to access, a boom lift. In a warehouse, again, loading, unloading, asset management. So this could be something as small as a handheld scanner, tablets for information as you walk around the facility. Construction, again, heavy equipment, safety, cameras for security. Construction theft is one of the biggest things. And then the list goes on: utilities, transportation, and then there are more and more that you could probably think of than me. In all of these environments, data is flowing and the data needs are there. We'll start to talk about some of the similarities, even if you're from a WISP background or an MSP. Any one of these environments is in your backyard, whether you're dealing with your county, your city, your state, or if you're nationwide. You can actually fit your data skills into any of these environments. And that's kind of what we're trying to promote here, or expand, is the knowledge that, you know, the network needs and the network implementations are actually pretty similar across the board. So let's go further and let's get into some of the specifics between oil and gas and mining. And in the future, we could do some more detailed webinars if the desire is there for some of these other verticals within the industrial environment. Okay, so oil and gas. So with oil and gas, you know, the environment looks similar to some of these very attractive pictures that we're using here. It could be an offshore oil rig. It could be onshore oil fields across Texas, Oklahoma. Most of the US has some kind of oil. There's also natural gas up in the Northeast. Above surface, you start drilling, fracking, and then pull up whatever the resource is. So again, it could be an oil sands facility, for instance. If you've not heard of oil sands up in northern Canada, they have oil that's actually above the surface, and when it freezes, it's easier to scoop. So you're literally not drilling, but you're actually scooping or shoveling this sandy oil substance, and then it gets further refined into something usable. So in that process, you have all kinds of production going on. There are vehicles shoveling, there are vehicles collecting, there are routes to get it to some kind of processing on site. Some of the processing could then be put into a form where it could be trucked out to a further refinery. There are pickup trucks moving around everywhere. There are facilities people with plumbing pipes, oil pipes, electrical lines all over a big open area. You can apply that mentality to, again, an open field, an oil platform in the middle of the ocean. When I say offshore, it could be as close as a couple hundred yards off the coast. It doesn't have to be miles away, so that could still be within your wheelhouse. But this, I emphasize, is all considered your backyard. If you have something nearby, all you have to do is look. Anytime I talk about industrial environments, I say this as a precursor for anything that we do. Safety is the #1 concern. You step on site on any of these locations, which I've been to many, and I've taken many of these safety trainings. There are national safety trainings classes that you can take. But once you get to a specific site, they will have a site-specific safety training to make sure that you were told what to do and what not to do. This is where you have the images of someone tripping over a hose. He has a head injury. They'll show pictures on the wall or in a slideshow. They'll show a bigger vehicle running over a smaller vehicle because no one was paying attention. So again, it's from massive incidences to small scale tripping over a hose. They'll always tell you that a fall from 3 foot is still a fall and could injure or severely damage a human being. So safety concerns are data driven. Safety concerns can be covered with cameras, sensors, proximity alerts. Someone opened the door, someone went into this facility, and then emergency responses. These are all wireless and wired data needs. And those, we'll get into the technologies a little bit later, but these are just some of the needs. In production itself, they're monitoring the vehicles. They may be looking at pumps. They're looking to control the pumps. They're looking to monitor the pumps to see how much is being extracted, if the machinery is actually working well. And then there are also just peer-to-peer communications to make sure that you could use, for instance, an LTE system for handhelds or vehicle fleet tracking type technologies. And then there's the environments. We already talked about there's offshore, there's oil fields, oil sands, and then just usually stationary refinement facilities. So understanding the environment is key when you try to approach some of these markets. In mining is very similar. It's just, we're not going for oil and gas anymore. We're going for things like coal, silver, bauxite. The environments are similar on above ground. Usually they'll dig a big pit. Usually some geologist will go, geology team will go and survey and find an area and say, hey, look, this area has maybe 10 years worth of coal. Let's go start excavating and digging for it. The digging could be near the surface, an open pit like in the picture on the bottom right, or it could be completely underground where it's further down and they start digging down and digging across into seams of coal. So the environments are different, but the functionality is quite similar in some ways. So in an open pit, you'd have haul trucks, those big trucks on the top right. Those trucks are about the size of a 2-story, maybe even 2.5-story house. The tire is definitely twice the height of a normal human being. So this equipment is multi-million dollar equipment that we're dealing with in both environments, oil and gas and mining. So the monitoring, the control, everything is based on cost as well as, again, safety. Safety concerns, again, cameras for watching areas, sensors for monitoring environment. So leaking gas, pollution, just dust pollution. If you have a mine near a town and it's kicking up a lot of dust, they might be monitoring that because there are rules and regulations around those sorts of things, as well as things that are toxic and could actually damage a human or the nature around it. So again, camera sensors, responsiveness, again, that's the safety team coming and responding to, well, someone hitting a button saying, hey, man down. Maybe you found someone unconscious because there's some silent gas out there. And then the response time, those are all data communications. In production, again, you have monitoring of the equipment, the vehicles running around, all have engine sensors. So same as your car is now telling you if the oil's low, if there's a vehicle too close. Our vehicles on the general roads are very intelligent. Well, a lot of that technology came from the industrial environment. In the industrial environment, they're dealing with a $6 million haul truck. They want to make sure nothing scratches, dents, or gets in the way of that vehicle, as well as the fact that a vehicle this size, there is no tow truck. So they need to do preventative maintenance. They need to know what's going on with this vehicle before it happens. We'll get more into that sooner than later, but those are some of the examples. I listed dispatch here. Dispatch is efficiency. So the efficiency of these vehicles running around to make money. That's essentially what they're doing. Every load of coal, every load of whatever the ore is that needs to be further broken down and taken somewhere on site and then off site, those things were all monitored via data networks. And then automation. There are environments around the world or even domestically in North America where, well, overseas a lot of times maybe the skill level is not there. So what do? We might want to have automated vehicles, unmanned vehicles doing the same job. Why? Because you want to protect your $6 million haul truck from running off the road, which does actually happen. Automation is a big push now, and automation is a very big keyword in getting in the door with a lot of these companies. We'll talk about that a little bit later, but LTE has become one of the premier products used or technologies used for automation. LTE, especially private LTE, which is non-carrier LTE for private property, localized to a private property. The properties of LTE actually in the frequencies that we use propagate really well in something like this open pit mine that you're looking at, or even underground. They turn corners really well, they reflect really well, and the data gets to the end user in a way that we've not seen with some traditional line of sight technologies. And then again, peer-to-peer communications that could fall also into the LTE realm as far as 3GPP for phones, tablets, etc. So you can actually build one network to support many of these different entities, the haul trucks, dozers, drills, etc. Whatever data is trying to be sent to those or come off of those moving and non-moving parts could be all into the same network. The environments for mining, again, I talked about them briefly. You have open pit, these big open pits. You have underground mining, and then oil sands is considered part of mining as well, since it kind of overlaps in oil and gas. A lot of the oil sands I've seen have been near an area called Fort McMurray in Canada. It's one of the largest mining operations in the world, especially for oil sands, to the point where when we talk about moving parts and non-moving parts, I believe they have one of the largest bus fleets in the world just to get employees around from main camp to mining sites, etc. And again, anything like that needs data. All right, so let's move on to talk about what some of the actual needs are. We talked briefly about some of them, but let's break it down even further. So again, I'll always lead with safety. I want to be the safest guy perceivably that they know. Like I said, I've been to probably almost 50 mines, probably done deployments on maybe half of those. A lot of site surveys, a lot of walking around, a lot of driving around the site to see where we could put infrastructure, what kind of radios or wired needs we might need. Can we do fiber here? There's a lot of fiber in oil and gas, but it's not always a 50-50 fiber and wireless. Each site is different, and it's good to do a site survey and figure all that out. Things get hit a lot, so overhead fiber is sometimes not great, but sometimes there are areas where no vehicles ever go, so fiber would be good and easy for that. So let's talk a little bit about safety concerns. One of the biggest safety concerns on any industrial environment is fatigue. The moment you have a human who loses focus, maybe his shift is ending, maybe they're not well, but they went in, Fatigue is monitored because, again, that guy could be driving that. I'm going to use this example quite often. That $6 million haul truck. One, his personal safety. Obviously, we care about the driver. Two, we care about the equipment and the cost. Three, we care about the safety of others. What could he do to other people? What environment could he create if he has fatigue? A fun example of fatigue mitigation would be on the vehicles themselves. They have sensors. So if another vehicle gets too close, or if he gets too close to a berm, which is the side of the mountain, a sensor will go off. In the last 10 years, we've had a lot of those in our own personal cars, but this has been going on for decades in the mining environment. So that is an accessory that you can add to the vehicle, but also there is a brain in the vehicle that will tell someone in dispatch, someone who's managing this guy, that, hey, that went off, he drove too close, we need to know, we need to talk to him, we need to do something about it. Airborne gas, that's an easy one. You're in a hazardous environment. There are gases underground. The gas that you're actually pulling, if you're doing some kind of fracking or something, you need to know where that gas is. A lot of times it's invisible, so you'll have sensors all over the place. Those sensors need to talk back to a main facility. Fire hazard, same thing. If I take electrical, if I'm working on something electrical, there's a lockout tagout process where I actually have to put a lock on the main so that no one turns power on while I'm working on it. So that might be me alone out in an environment. Maybe there should be someone watching me, or some kind of handheld communication that I check in every now and then. Those play hand in hand with fire hazards too. Road safety. So road safety is actually a fun one too. We talk about the haul truck. Those tires, if the vehicle costs multi-million dollars and the tires cost multi-thousands of dollars, up to maybe $100,000 for a tire, that those big tires, actually there's a used market for those overseas. How can we use road safety to mitigate that kind of damage? Well, there are sensors in those vehicles that will tell you where a pothole is. So if you are doing some geolocation on the vehicle, and every cycle around the plant, there's a bump, there are actual technologies in the mining industry that will sense that in the vehicle, and someone can go out and fix that pothole. That pothole will save money on the tires, and it'll save wear and tear on the vehicle, and it could even save an accident. And again, I always refer back to emergency response teams in these environments. Anytime you drive into a mine, an oil field, once you get through the gates, you'll see a sign typically that says 100 days since last accident, 200 days since last accident. Hopefully it's a very long time since last accident, but these are the first and foremost things that they want you to think about, is safety, and having an emergency response team with good data connection to, one, maybe even view the situation with a camera, and two, have two-way communications through a digital system to get people there and report the incident as well. I'm not going to go through everything on this slide, but I do have a story on most of these things if you want to talk to me offline. Production, again, is one of the big ones. We are a production facility, right? We are producing this much gas per day. We need to increase production. How do we do it? There are analysts looking at everything. There are dispatchers looking at the trucks, seeing if there's a better way to do this. Driver A did it in 10 minutes. Driver B did it in 13 minutes. How do we find the middle ground and see what the most efficient way of doing this is? And again, every load has a dollar amount assigned to it based on what you're carrying. If you want to know prices, go look up the price of gold, go look up the price of coal daily, and it changes. And they will use those numbers to determine how efficient a facility is. So we discussed maintenance before failures. So the vehicles, we want to have all kinds of monitors on the tires, the oil pressure, everything that you might see on a car, triple that, and that's what they're looking at on any of these industrial vehicles. A dozer, a drill could break, a drill could be drilling in the wrong place, and that could be damaging, and so forth. Conveyor belts underground. Well, conveyor belts are the lifeline of a lot of underground mines. They need monitors along the way to understand if there's a broken part, if something's about to get stuck. What is the age of the conveyor belt? What is the age of the rubber parts that could fail first over the metal parts? And then cameras and that sort of thing, watching all this stuff happen. And then making sure that if an alarm goes off, it is going to be read by the receiving entity, whether it's safety or production. You know, it needs to be real-time data. So these are all the things that we have been doing with a lot of the products that we use. We're monitoring, we're just sending a data feed, and whatever's being sent across that, we're all pretty familiar with that. Again, daily statistics, like I said, there's an analyst or an analytical group looking at production and seeing how we can improve or maintain the way we're doing things. Cameras are usually, to me, the lifeline when we talk about environmental, or the lifeline of a big property. You can sit in the main office and view every part of the network. Cameras, as we know, are a bandwidth hog, but nowadays we have a lot more bandwidth available to us with new technologies coming out daily. Something that in my years working in the industrial environment, especially mining, we were replacing technologies that might be 16 years old. They're not always fast to move, but if they have someone like yourselves going out and visiting them quite often and explaining some of these new technologies to them, and how like cameras can now be very, very high resolution, high frames per second, because there are a lot of moving parts. But now we have the pipeline to do it with much higher capacity fiber and wireless technologies. Excuse me. Again, sensors, we talked about that a little bit. Air quality sensors are probably one of the main ones. One of the fun ones I saw was in mining. They are blasting. There are explosives on site, and they're blasting off sometimes daily, whether it's underground or open pit. You need to know what's going on. So you might blast on the east side of the open pit mine. You might have a GPS sensor on the western side of the mine to see if your blast on the east side had moved anything detrimentally on the west side. If that sensor moves a foot, that means that you had an effect on the west side of the mine, and that could lead to future problems. Could it lead to an avalanche? Yeah. Could it lead to a crack? Could it lead to something that we need to watch? We need to watch everything. Sensors are also the lifeline of the industrial environment. And then responsiveness. How do we respond to that? Do we know that we will take a week and go send a geologist out there and take a look at it? Do we need to keep watching the data on that one GPS sensor to see if it's going to move further or if it stays the same for the next couple months? Again, analytics are everything in these environments. Excuse me. And then there's just production. We talked about that too. Production is knowing the quantities of material moved, extracted, refined, etc. We also need to have some control over that. So imagine it being similar to a building where you have pipes running all over the place, some for water, some for gas, electrical controls. We are supporting a massive micro environment, which is a facility. There's also dispatch. Dispatch is the human communication to each other. Dispatcher to driver. They're always checking in. Driver one backed up. dropping, picking up. They communicate in that way, as if to make sure that there's not just it's a very verbal environment. Most of these are very verbal environments. We talked about automation. Well, automation applies to the vehicles as well as systems. Stationary items include the crusher, for instance. You pick up ore in the haul truck, and then you take it from the pit to the crusher. The crusher further pulverizes the ore for refinement. So let's say you have rock, and in that rock there's gold, silver, and copper usually found together. You need to further crush, then you need to maybe send it through an acid bed to separate the metals from the rock. And then even further and further, there's a lot of steps to refinement. A lot of that can be automated because it may not need human interaction, as well as using automation to enhance human interaction. And then again, we talk about peer-to-peer comms. We've talked about that quite often in this talk. The key that I'm really getting to here is that it could take one pipe of data to make all of these things happen. You can set VLANs for monitoring, VLANs for control, VLANs for dispatch, VLANs for automation, or you could have dedicated links, whether it's fiber or wireless, to each of these endeavors. We're going to talk about the approach in a little bit as to how we can do that. But understanding all of these elements that need to be taken into account is very, very key. So what does it look like? It looks like a little bit like craziness. If you go to a mine, if you go to an oil field, if you go on a refinery, it's just a lot of metal, a lot of things going on, a lot of lights, a lot of signs. Don't do this, don't climb here, be strapped in, fall risk, lockout, tag out. There are a lot of things going on, but it's not that hard to understand. If you look at vehicles do need a wireless connection, mostly. They usually have some kind of two-way antenna on the top for actual two-way communications. That is becoming digital now, even though you might see very antiquated facilities. A lot of them will sit on a technology for a very long period of time because it works, because they don't like change. There's an industry out there called change management, where they have to go in to some of these facilities and teach them how to use the new software, teach them how to use new technology. There's actually money to be made in that, but that's very easy. Once they're trained, they're going to be like, oh, wait, my cameras are doing way better. My two-ways are doing way better. This road is much smoother. Once you get the technology and they feel it, they're going to love it. But they will sit on technologies for quite a long time, in my experience. I started in the industrial specific environment in the late 2000s, early 2010, 2011, and so forth. And we were replacing 900 megahertz communications for all of the above that I just described. Well, now if you have a big piece of data, bigger pipe, you can do more things. The cameras aren't sketchy. We used to debate whether we wanted cameras on the vehicles because that would have been a bandit with hog. Now we can easily do it. You can put cameras wherever you want almost, if you have the right technology. From this image, what we're trying to project here is that this could be a mix of wireless and wired. Typically non-moving facilities such as the office can be fiber fed, and fiber can be redistributed out from there to other offices, connexes, storage sheds, auto shop, those sort of places, all the way down to, on the far right, some kind of crusher or production machinery. So there's a lot of good mix there for fiber and wireless. You just got to make sure what hazards there could be to the wired infrastructure as well as the wireless. A lot of things like the solar trailers that you see here, there's no power. There's not power everywhere. So solar trailers are a big sell in this environment. I could put my wireless CPE anywhere I want if I have a solar fed trailer with a mast on it. Winncom sells those. Then you could put your air sensor on that, or it could be a relay or just part of the bigger network. But even when you put a solar trailer out, you got to be careful where you put it. It could get run over. It could get squashed by a big haul truck. Just someone in a pickup truck could back into it. You want to keep everything out of the way in these environments, not just for safety of personnel, but for safety of the equipment itself. On a conveyor belt, if you're underground, wireless all the way down will be great. Even if you have fiber, even if it's a stationary process where the conveyor belt's going all the way down, well, things could get cut. So do some redundancy, do some wireless redundancy there. On a dozer on the top, there is a process for that. There's a geologist that went around and surveyed the area in a mine, for instance, and said, hey, look, this is the best place to start digging, to start moving material. They call it material for best efficiency, that we're not wasting our time in a place that has maybe a year's worth of ore. We can go over here with a seam that can keep us in the money for about 10 to 20 to 30 years. Some of these places have a production run life, and they'll tell you we're projected to be here for the next 100 years or so, doing coal or extracting gas or something like that. They know these things. The technology's there, the science is there, everyone knows these sorts of things, and the money will flow into these facilities, and then the needs will grow as we add more technology. Excuse me. So the data needs are everywhere. Let's talk about what applicable technologies there are. Well, going back to Winncom and Winncom's partners, we provide pretty much all of it for the communication side, whether you're utilizing ONTs and LTs for that wired infrastructure that I talked about, fiber in between, SFPs, switches, etc. Once you get further into the extreme points of the property, you might need wireless, or you might still need wireless to subsidize the wired. So again, if a fiber line gets cut and there's no redundancy, that could halt production for a day, could halt production for an hour. They know how many dollars that will cost a facility per hour, per day, per half day, and maybe we should build in some redundancies. So fiber and wireless, wired and wireless are key everywhere. But then you will get into some remote areas where wireless will only work, and we have the wireless products for that. Some of the manufacturers that we sell do have hardened equipment. I'll talk about hardened equipment. Hardened equipment relates to how rugged the equipment can be in certain harsh environments. Harsh environments could include extreme heat, extreme cold, vibration, physical damage to the enclosures. So instead of a plastic type enclosure for the radio, there are metal enclosures that will take a hit. When you're blasting, or there's a collapse or something, just big vehicles bump into big things and cause damage. There's also the IP ratings, IP67, IP, etc. It's not just water intrusion. In these dusty environments, I've walked into server rooms that have a complete layer of orange dust. My laptop almost had a complete layer of orange dust for the duration I was on site. So there are a lot of things that can intrude into an enclosure, into a switch, into any kind of piece of machinery that could over time damage it. So look for hardened equipment. I've also found that in some environments, you don't need hardened equipment. If you're off in the office area, there's no chance of a rock flying from the blast area, because usually they'll build those facilities much further away. Any oil derrick or oil pump could explode. They can sort of take a hit. We have cameras that are hardened. We have explosion proof casings for cameras that will at least stay alive long enough to tell you what happened and beyond. So hardened equipment, non-hardened equipment, choose your environment well. Understand where you may or may not need it, but it is a good sell that a lot of our manufacturers have played with. Mobility is another thing. So a lot of our point to multi-point technologies can do nomadic mobility. This is not high speed. Most of the time in a mining environment or oil and gas environment, no one's going real high speeds, but we also do have technologies that can go higher speeds, such as LTE type technologies and that sort of thing. So it's good to have a site survey, go check out the property, see what the needs are, and then see, where you would apply each technology. But these are the same technologies that we use in a WISP, same technologies that we use in the municipality, same technologies that can be used in multiple environments. You put up a tower, you maybe have to have a backhaul to the tower, whether it's fiber or high capacity multi-gigabit broadband, and then you put a multi-point system up, whether it's LTE, whether it's to brand, you'll find the right technology for those environments. Where the shoe fits, we'll have it. It could be oil derricks all over a several acre property that have microtick, small microtick bullets all over the property, because they just need to monitor small amounts of data. And they know that some of these environments, so the opposite of hardened is, I hate to use the word disposable, but easily disposable. So a lot of microtick low cost equipment is put out there because they know they can quickly replace it. One of the other things about the mining environment that I want to throw in here too is a lot of times you have IT managers, but they may not know about all of the technologies that they're selling. Sorry, not selling, but implementing. But you sold it to them, so you would then become their support entity and come in and have them sign a support contract, and you can come in and be the guy that replaces them, mounts them, aims them, et cetera, does the trenching, et cetera, because you know better than they do. They just want to manage it after that. That's a very typical mentality in a lot of the mining environments that I've seen, as well as oil and gas. It's kind of like they are very contractor-led, and you will be their contractor. I talked about LTE. For those of you that aren't familiar with LTE, we're talking mostly private LTE, which is small property, does not conflict with carrier frequencies and carrier technologies. If you think about where mine is, if you think about where an oil field is, they are off the beaten path. You have to fly to the middle of nowhere or drive to the middle of nowhere and go even further into the middle of nowhere. It's very rare that you'll see a mine or an oil field from the side of the road. Maybe certain areas, West Texas, that sort of thing. But usually there's a gate with a not very loud sign, and then you have to drive maybe even a mile down a dirt road further into the property. Being remote like that, you can get into different frequencies for LTE and wireless products that you may not be able to use closer to the highways where the carriers are, right? If you think about where the carriers are, they're in the middle of Nevada, for instance. They're mostly covering the highway, the interstate, and then a little bit of ground east and west of it, north and south of it. But once you go into the boonies where a mine might be, you might be able to pick and choose the frequencies you want to use in private LTE, because you may still need to get permission, but you're just proving that, hey, I'm not near the highway. Private LTE now enables you the ability to put up an E2B on a tower, and you're not limited if you're using 3GPP or some kind of proprietary protocol, you're not limited to now using that brand of eNodeB's CPEs. You can mix and match your CPEs as long as the technology is the same. You can add phones, you can add laptops, you can add all kinds of ancillary devices, even a CPE that will plug into have a sensor plugged into it, or multiple different things plugged into it for that monitoring and PLC type technology. So you could have everything over one network. And again, those manufacturers come in all kinds of flavors. You have Bicells, you have Ericsson, you have Nokia, etc. We have quite a few, and I'll show you the line card in a couple slides from now. And then don't forget the sell of the ancillary items, the accessories, cabinets, solar power, solar trailers, surge arresters, power systems. So we have ICT, we have NUMAR, we have all kinds of ways to do plant power. And then also there's the NMS, the monitoring of all this. These are all things that we as a distributor sell to you guys, and you will resell to your customers. And I want to emphasize that the learning curve is not that big from what you might already be doing. So expand out into different verticals. So I just want to talk really quickly about the approach. The approach is maybe the same as what you're already doing. For some of you that are already in this environment, you already know what to do, but just understand that the similarities from what you're doing in oil and gas and mining could apply to a warehouse nearby. The Walmart facility, distribution center, every small town, major town has distribution facilities for production. So you might just be doing that in a smaller scale. Or if you're doing small scale, you can take this to larger scale. So how do I enter into a industrial environment? Well, again, I talk about safety. Make sure that they know that you know what the safety training is to set foot on their site. Maybe it's electrical training, maybe it's OSHA, that sort of thing. But I've seen people enter these properties just doing simple point-to-points. We need to connect 5 buildings. We need good data. You'd be surprised how many of these multi-million and multi-billion-dollar companies are using some of the worst technology for point-to-points connecting buildings. And it might be just because the IT personnel on site just knew this one product. It's easy to use, it's disposable, we use that. But us as resellers and distributors want them to have the best in class, best fit for the project, and maybe some better security, some higher functionality. That's your foot in the door. A lot of times when you get in a meeting with these guys, they'll talk to you about the hard to reach sites. Sometimes your infrastructure can't reach it, but we do have satellite technologies and solar power to give us more remote access to things. So playing with the ideas, that's the fun part of it, is playing with ideas. How can I get something where there is nothing? No power, no infrastructure, no nothing. Talk about refreshes. We've talked about this with a lot of our partners, and I talked about how in 2010 I was replacing 16-year-old technology. So in 2010 I was replacing stuff from the 90s. We live in a technology world where if I had a TV from the 90s, I would be miserable right now. So why are they using a multi-million billion-dollar facility using things that old? And then talk about a refresh plan, because technologies are getting replaced every 2 years. So these guys their eyes might wide open. They might create budget for technology refresh to make things more efficient, to make cameras better, to make the user experience just that much better. So that's where we go into capacity needs. Exploring the options and limitations, we're talking about unifying all the departments. So let's talk about culture. Sometimes you enter a property or a company, some of these companies are nationally or globally driven. But once you get down into the weeds of the individual sites, they might be forgotten or dominated by corporate rules. Well, they always have to fight back and say, hey, look, I'm in this environment, not in the environment of the other facility across the country, that we have different considerations. Within that property, you have different departments. So you have the electrical department, you have the dispatch department, you might have a water pumping department, and they all have hired their own little contractors to put in a wireless system or a communication system for those, or the communication system that came with those products. Well, unifying all those departments is the best way to enter into that sales environment to me. Hey, we're going to put everything on this network. We're going to create VLANs. We're going to separate the traffic. We're going to create QoS. We're going to create different priorities. No one's going to lose anything. But what we're not going to do is have everyone on the same property fighting over a 5 gigahertz frequency and dividing up the channels, and no one's talking to anyone. You could be the unifier or help the IT department be the unifier of all this. That comes with determining not just what is known, but what is unknown, going and asking all the other departments, pulling them all into a meeting and seeing how we can come together. It's like making all of the wireless entities in the municipality come together and talk in a friendly way. And then talk about future-proofing the system, and that'll bring them all into the same page. Don't forget that solutions can be mixed bag. You can mix products, you can mix manufacturers. Don't be limited by a specific product. Be driven by the solution. That's what we do here at Winncom, and we hope you guys do it too. We can definitely help you with different ideas as well. Pulling as many brains into a room is the way to go with these guys. So then an example would be LTE for mobility, broadband for cameras, fiber where it will not get damaged. Fiber is the heaviest carrier right now, but it is easiest to get run over, get cut, etc. in these environments. Here's a quick look at something that you can study later. These slides will be distributed, but when I say do a mixed bag, think about the solution. A lot of these technologies can tie together. A lot of these technologies have hardened equipment and non-hardened equipment. A lot of these technologies are accessories to the technologies that you will use. Don't be afraid to come to us and ask our engineering team for help. You may already know a lot. We may just reaffirm what you already know, or we might bring up some red flags that you don't know about. We may know about new and exciting technologies that have just come out that we've heard about from our manufacturers. We have a direct relationship with all of these manufacturers, and we'd be happy to help to introduce them into whatever environment you're working on. I think that's the end of it. Sorry to speak a little fast toward the end because we are running out of time. Again, this is me, Dave Thakurdin, from the Winncom engineering team. We do a lot of sales support and customer support when it comes to design, product, advisement, making sure that you have the right stuff from our sales team. I would now like to open it up for questions and answers. Donna, do we have any questions?
Sure, we have a couple questions.
Okay.
The first one, where do I start looking for industrial verticals in my region?
Anywhere. So if you're in a county, there's probably warehouses, there's probably construction coming up. Maybe a new construction site has no connectivity. In oil and gas, you can definitely do lookups. Go to a lot of the oil and gas shows, mining shows, trade shows. Those are always good places to figure out who's who in the world and in your world and what kind of technologies there are out there. I've learned a lot from trade shows on what the newest ideas are and needs. And then just a quick look up. We visited a customer who is primarily a WISP, but he does have a network of towers across the county, and there was a fish hatchery that he was inquiring about, and we said, yeah, you could, wherever the data is, that's probably a sensor-driven kind of environment where they're looking at the water quality, the production, the loading, unloading, that sort of thing. wherever you think there's production going on, storage, that sort of thing, it's endless. The environments that you get into.
Okay, great. And we have one more here. What kind of safety training is best to have if I wanted to get my employees into industrial verticals?
Okay, so that's a good question. Each vertical will have its own training, and that can also be looked up. For instance, in mining, oil and gas, there's MSHA training, which is a derivative of OSHA training. So OSHA would be one of the key ones to just show and put it on your business card or your website that you have technicians who are OSHA certified, MSHA certified. MSHA, you can take that online. There are also, I live in Colorado, so we actually have a school of mines where I go and get my MSHA training. And it does teach you all of those things that you need to know to walk onto site. But yeah, every environment's going to have, and they'll tell you, once you approach a customer, they'll tell you what training they require for you to actually do work on their sites.